Okay, so we're going to start on page 11 with the warm-up today. You will also need your graphing calculator because we're going to do some statistical calculations with the features. So have that out too. So on page 11, pause the video here. The graphs below show distributions that are not normal. What property shown makes them not a normal distribution? So try these three graphs before you watch the solution. Graph A is skewed right. This is the side that's been pushed away. Graph B is bimodal. There are two parts that have the most data. It's an AL, not AI. And then graph C is skewed left. What? No. All right, so now on page 12 and 13, we're going to start today by talking about the effects of the mean, which is the average, and standard deviation, which is the spread of the data. So on page 12 and 13, it starts with our task. Jim has taken 4 exams in his stat class. First score was a 92%, and then an 84%, and then a 96%, and then 100%. In the typed part here, it says both the MAD, which is mean absolute deviation.
All right, Q07 students, all 10th and 11th.
And we're never going to do the mean absolute deviation in Honors Algebra 2. You can cross all of that out. We will calculate the standard deviation. So standard deviation is used to measure the variability of a data set. So it is how much the data varies, how spread out the data is. So we're going to calculate standard deviation with our calculators. This is the steps, these steps right here that are now blue, are how we're going to type the values in our calculator. And this is the output it's going to give us. So pause the video here and write down these steps and take out your calculator. Okay, so to start, we're going to hit the stat button, which is over by the arrows. We're going to go to edit. And my calculator has no data here. If yours does, you can go up to the list name and hit clear, enter. Do not hit delete. If you hit delete, this button, it actually deletes the whole column. We don't want the whole column gone. We just want the numbers gone. Like, watch this. So I have these numbers. I don't want them there. I'm going to go up to the L1 and I hit clear, enter, and it gets rid of the prior data. All right, so we're going to type in the numbers. So 92, enter, 84, enter, 96, enter, 100, enter. And now we have to quit. So that's second mode. This gets us back to the calculate screen. Then we're going to hit the stat button again. Now we're going to go over to calculate, and we are calculating a one variable statistic. We just got one set of data, test scores, hit enter on number 1. I have a newer calculator here that gives me this stuff. If you have an older calculator, yours will just, Sorry, I thought the announcements were over, but apparently they're not. So if you have an older calculator, your calculator won't give you this. These newer ones give us this extra stuff. I'm going to hit enter on calculate. And ta-da, there we go. So X bar, that's the average, that's the mean. So we're going to write that down. X bar for these test scores is 93. His average test score is 93. And SX is the calculation we're going to be using is 6.83. we're not going to use the little sigma, we're going to use this SX. So the two numbers you're going to focus on are X bar and SX. So X bar is the mean or the average, XX is the standard deviation. All right, so we calculated the standard deviation. Explain how this value represents the variability in his test scores. So standard deviation just by itself for one person is not as helpful as then when we're comparing two people. So with Jim's standard deviation here, it's 6.8. Okay, so not small, not big. Well, we need to compare it to something else. So let's look at Sally. Sally took the same exams and also had an average of 93. Both student scores are displayed in the dot plot below. Without calculating, determine if Sally's standard deviation is larger or smaller. So the spread of the data, the more spread, the more variability. So we're going to write more spread, more variability, which means larger, larger standard deviation. All right, so the dot plot, you might have to turn the page to see the dot plot. So here we've got both of them have an average of 93. Jim had a standard deviation we wrote of 6.83. So looking at Jim's scores, we got this one down here, this one up here, pretty spread out, really spread out. But if we look at Sally's test scores. Here's 1, 2, 3, 4. They're much closer together. So we can say, and it's hard to write with this tablet, so I'm going to type, Sally's standard deviation is smaller than Jim's because the data is closer, clustered near the average of 93. Whoop, sorry about that. So because right here is that average of 93. Sally's scores are much closer. They're clustered closer together around that average, whereas Jim's has these test scores that are more spread out. All right, part D. Tom also has the same exams, but his average is a 91. His standard deviation is 0. What scores did Tom receive on his exams? So we'll pause the video here and you write, what scores do you think Tom got on his exam? So I'm going to say Tom earned a 91 on every test, every exam. No standard deviation means no variability. So 0 standard deviation, none of his data varied or changed from 91. All right, so we're on 14, we're going to skip this mad mean absolute deviation. We're going to go scroll down, or you look down. I'm going to scroll down to the bottom. And let's practice one more time in our calculator to see if we can get the standard deviation. So bring your calculator back up. I'm going to hit clear, get rid of the calculations from before. We're going to go to stat, edit. And now to get rid of all this data, we're going to do clear, enter. Do not press delete. Clear, enter. And now we have to type in the number of pets. So we're going to type 1, 1, 1, 2, 4, 4. Oh no. 2, 4, 4, 8. Okay. And I'm I'm going to quit second mode, back to stat, calculate, one variable statistics, enter, 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 because I have a newer calculator here. And we see standard deviation 2.52, that matches. The average is 3 pets. It's a lot of pets. So what does this standard deviation tell us about the data? So if the average is 3 pets, standard deviation is 2.582. I can see that here. What does that tell us? 2 is pretty close to 0, not a very big number. So this tells me that the number of pets is clustered around the average. That most people have the number of pets around the average of 3. Okay, so now we're going to start, you can put your calculator away. We're going to start analyzing some normal curves and see how they show us average or mean and standard deviation. So what does standard deviation tell us about a distribution? Standard deviation tells us how far from the average the data varies. Now we've got each distribution shown below are normal distributions that have the same mean but a different standard deviation. Let me make this smaller so I can see them all. Here we go. So I can see here there's a mean of 3, a mean of 3, and a mean of 3. They all have that peak at the average of 3. But this one has a standard deviation of 0.5. This one has a standard deviation of 1. And then this one has a standard deviation of 1/4. How does changing the standard deviation affect the normal curve? So let's generalize that. I'm just going to type it up here. The larger standard deviation versus the smaller standard deviation. What's the difference? What do you notice about these curves? Okay, so for larger deviation, we've got a wider curve with a lower peak. And the smaller standard deviation, the 1/4 and a half, that's a more narrow curve with a higher peak. So small standard deviation means the data is clustered around the average. Most of the data is close to the average, so it pushes the peak higher. A bigger standard deviation means the data is more spread out. Some of the values are further from the average, making the curve more spread out. So now in 16, turn the page. What does the mean tell us about a distribution? The average. What does the mean tell us? Where can you see the mean on a normal curve? A normal curve, mean is the location on the x-axis of the peak. I look along the horizontal axis, the value where the peak occurs is the average. On each of the distributions below, they're all normal and they have the same standard deviation. They all have a 1/4 standard deviation, but a different mean. This one has a mean of 1. This one has a mean of 2. This one had a mean of 3. So how does changing the mean affect the picture here of the normal curve? So I noticed that the larger the mean, the further to the right on the x-axis the peak is. Smaller the mean, the further on the left of the x-axis. So I'm going to say the larger mean for x bar is translated right on the x-axis. Smaller mean closer to the y-axis or 0. This is the peak it is. There you go. That's more precise. So the peak of the curve, that high point where most of the data is, where that average is, slides, it's translated, it shifts along the x-axis. Okay, on page 17, pause the video here and answer numbers A through D on number 5. Okay, so now we figured out some of the features, determine if the following are true or false, and in each case, explain. A normal distribution depends on the mean and the standard deviation. I'm going to say true. The mean is the location of the peak, and the standard deviation is how wide and how high the peak is. The mean, median, and mode are equal in a normal distribution. True. That is part of the definition we did yesterday. A normal distribution is bimodal. False. We did that on the warm-up. Normal curves, or a normal curve has one mode. In a normal distribution, 50% of the population is within one standard deviation of the mean. That's false. That is false. Yesterday, we looked briefly at the empirical rule, or that, ooh, I spelled false wrong. The empirical rule, or the rule that was 68, 95, 99.7 rule. That no, 50% is not going to be within one standard deviation. 68% will be. So here's my sketch of the empirical rule, or that 68, 95, 99.7 rule. And what it's showing us is that one standard deviation to the right and one standard deviation to the left is a total of 68%. Two standard deviations to the right, up to, and two standard deviations to the left will be a total of 95%. And then 3 standard deviations to the right and 3 standard deviations down, so negative, will be a total of 99.7%. The leftover outside is these tiny percents. So you don't have to memorize every single value here. The 68, 95, 99.7, we can use that to get the remaining portions. So for example, I know, let me get a different color in my pen. That 68% is on either side of the mean here. So how much percent is left is 27%. So 27%, if I divide that by 2, you're not sure you got your calculator on everything. That's that 13.5% for here and here. It's saying between these two standard deviations is 95% of the data. And I took away the 68% I already know. And then lastly, to get to the 3%, to the third standard deviation, sorry, I'm going to take my 99.7% of the data and take away the 95% that's already there, or 4.7% divided in half to get me the 2.35 for these sections. Well, 0.3% is left over, divided in half to get me the 0.5% on the outside. So your homework is page 19 and 20. Don't forget to check your answers in Drive. You're going to use your calculator to calculate some standard deviations. So have that nearby as you do your homework as well.